Okay, this is part 2 of the video on wind production, and I suppose I should say hello to you. Like people in these other videos, they say hello, hello, hello. Okay. Now, I was hoping to find something more dramatic than I found with this. All right, and I'm going to show you some technical details of how this all works a little bit later, but we can start by looking at some of the wind farms. Take Dinosaur Point. Okay, what I did is notice how 2014 is not here. 2009, 876. So this has a lot of data. And the standard deviation in the production compared to the average production was about 8%. I was frankly expecting it to be less. This one was 11%. Another one that's 8%. And the nice thing is you can look at this now. Cameron Ridge, okay? We'll take a couple of the other, let's make a couple of the other statistics. Now, if I wanted to compute the P99, we'd use let me step back, okay? Excuse me for this. The real key and the real theme of this video is to not put grid lines in. Just kidding. The real theme is to discuss for an existing wind farm, what kind of risks are there after the commercial operation date? What kind of risks do you take as an equity holder if you're going to invest in the wind farm? And what kind of data can we see from existing wind farms, and can we learn from some of this data? I think that there might be some lessons here. I wish we would know more, like this one, about what really happened. Maybe there's a little bit of a trend downward that we should be worried about. But how much, the first question is how much the deviation is. Now, if we would want to compute the P99 after the fact, not the P99 before the fact, we'd use a wonderful formula called norm inverse. So part of the theme really is just to show you this as well. And then the other thing is to discuss how some of the technical details work. But the real question is how much is the pure variability of some of these productions, this one thing that we really can't seem to control. Now, if I put 1% for the norm inverse, I can get the P99, and then it asked for the mean, which is the average. I've got the standard deviation, I got the average, and then I got the standard deviation. Okay, so this is if the average was this, the standard deviation is here, and so if we want to take how much is the potential reduction in our oh no, what did I do? Okay, shit. 1 minus let's take the P99 divided by the average, and then let's take the 1 minus that. Well, I can't seem to do that, and I have to press Shift Control 5, and because I don't have the, I don't have the generic macros open, I have to do it by hand. Okay, so we have 11.82. That's kind of our downside case in this extreme low case. Okay, and we'll do the same thing, norm inverse. Excuse me. I don't know. I'll take this one. And then let's put 5% when we put the same thing in. The mean, this time I'll press F4, and the standard deviation, this time I'll press F4. All right, and then we can do this one. So the P90 will put 10%, and P75. hopefully take the same formula and just see, well, okay, for 75% of the time we should be within 3%. 1 out of 100 years will be within 11%. 1 out of 10 years will be within 6%. That's how we interpret it. And then the interesting things. Now this, I would say we can't use this. It would be really interesting to see what happened. They closed some wind farms or they had some problems. Now we could take this out and we can look and see that the standard deviation would be a lot less. Here's a case where there might have been startup problems that's affecting the deviation. I really perhaps should have taken a 2000. Well, I'm not going to go and do that. It's just to do it all by hand. Here's one where we've got some declines. And again, I'm kind of looking at, I'm saying again, when I look at these things, let's take this one. Okay, we'd like to understand if there were some bird or avian problems or what happened here, and then we've got a pretty high deviation. So even in the we can have a 10% reduction in the P75 case. Okay, here's one with 9. Now I'm gonna let's go back to a couple of these ones. Okay. This is, I was expecting to have a lower deviation. Even this for me is a pretty high deviation. You can see kind of how it's smoothed out and all of that. But my theory, which perhaps is wrong, was that, you know, the risk of these things really declines dramatically after you've built them. So we have much smaller deviation than the kind of deviations you'd see in an actual study. You know, oops. Oh, no. Okay. Shoot, I should fix that somehow. Okay. Oh, crap. Okay. I'm gonna do something. Whoops. Oh no, I went the wrong way. All right, and let's go to some of these. So I should be going up. Excuse me for this. Okay, I'm going up fairly quickly. It's can't you get addicted to this kind of stuff to see just what the kind of standard deviations really are. These are interesting ones where they skip some data. This is the kind of numbers I would expect more, a kind of 3% standard deviation in this case. And this has a bigger one, but some of these ones, 42, that's pretty big. Okay. Keep going. Okay, so these, enough. I guess enough. I was going to show you there are a lot with pretty low standard deviations as we get down. Okay, here are some examples. 0.55, 1%. They're only a couple of years, 3%, 1%. 3%. So this is the kind of numbers I was expecting much more to see, that these relatively low. Perhaps we should put the area where the wind farm is and look at it a lot more. But it's and again, this is the number maybe to really look at to start with. Okay. All right. Some of the okay, don't repeat myself too much, but the trends are kind of sometimes more important than anything else. And enough. Stop. Okay, now, I don't really need this anymore. Let's just take you quickly through how this works. First of all, I had a mistake in the first one. To find the first column, I thought this match function would work, and it turns out the match function didn't work. So this starting column actually came from I had to write, and it only took a few minutes to write a function. And the function basically says, okay, give me a row number, and then give me a column start and a column end, and a sheet name. The sheet name is a tiny bit tricky, but just if the from the start, go around the start column to the end column, and look in the row and the column, and when it's above 0, just stop. And that's all it is. Why? I wish there was some functions like this in Excel. The functions basically fix Excel. Now, once you've done this, you get a starting point. So this is desert sky. Okay, and remember we put a row number and a column number, and then we took the whole sheet and used the index function to find the production. Now the trick is a little bit. There's a first thing. This is how we made the graph of the other one, where we put an NA when we stopped. However, that didn't work perfectly. Remember, if we have these NAs, it kept showing them, and I don't think that's so bad. Oh shoot, another phone call. I've got to pause. Okay, let me try to finish this now. What I tried to do to make those other graphs is then to make a little thing where we just figure out when we have a full year. The first thing to do is to put just a year counter in, okay, and then increment it by 1, and then use a count if. And you just count if on the year, on the full year, and see when you have the 12 months. Okay, and then I put an if statement. Now, if this is equal to 12, then we use the sum if. If we've got 1 month or 2 months, we don't sum it. Okay, and then we can count how many different years have 12 months. That's what we do here. And then we get the average with the false. Okay, so this is only the average when we get the full 12 months. And then we can make a little count, and whenever this is false, we don't count it. So when it's a full year, we do. So this, we eventually go to 1 and 2 and 3. I hope there's a 2 somewhere in there. There's a 2. And then we can use the match function to see the max. So you don't really have to do this. Match the minimum of the whole column against that. That gives you the row number of the minimum. Take the maximum and do the same thing. And then I just do a count. 1, and then we say, well, we go up to how many years we actually have, and then we can take the column number with another match. Going crazy with match and index like I do in a lot of these data videos, and then we take the index of that, and we take the index of the production. So this just allows you to make the little graph. I had to use the offset function, Control F3 to find the offset function, and we just counted up to this number. So that's how the graph was made. You can obviously look at the file. So that's it. And you know, here's another one. This is a more typical one. I don't know what happened to the intervening period. Again, I'm pretty sure I downloaded all the files, so it's not perfect, but you can really see some of the actual deviations. And there's a 1%. That's what I was expecting to really find. Obviously, this one's in a place called North Dakota. Okay, and then this one that says, well, even in the 100 years, of course, we have 2 years of data. That's not a very good statistical thing to even talk about, really. Okay, so there we have it. And then, as I said before, now we'll do the same sort of analysis. We've got all the data. We'll do the same sort of analysis with solar power instead of the wind power. Okay? And goodbye.